So for problem number 40, we have here two pulleys and it has a radii of 15 centimeters and 8 centimeters respectively. The larger pulley rotates at 25 revolutions, 25 times per 36 seconds. Find the angular speed of each pulley. Well, the angular speed is the number of rotations. So obviously the angular speed is going to be right here. That's omega equals theta over time. Theta, of course, is radians. So first we're going to find the angular speed of the larger one. So the larger one here is at 15 cm. And we know that our angular speed is the radians over time. And in this case, the radians is, of course, 2 pi radians. That's what we're trying to figure out. Radians over our time is 1 second. And we're going to be timesing that by what we're given, which is 25 revolutions for every 36 seconds. The 2's cancel. So this changes to 18. So our angular speed, using omega of the larger pulley, is going to be 25 pi over 18 radians per second. That's the angular speed of the larger. Now we're going to get the linear speed of the larger, because that's going to come in handy for something else. Helpful if I spell linear correctly. So linear velocity is going to be related to the length of the radius times the angular speed. So in this case, for the larger one, that's going to be 15 cm times 25 pi over 18 radians. We can reduce this, of course. 3 goes in here 6 times, 3 goes in there 5. So my linear speed is going to be 125 pi over 6. And our units here are centimeters per second. So that is my linear velocity. The trick to this entire problem is to realize that although the angular speeds may be different, angular because it's related to number of rotations, and of course the smaller will rotate faster than the larger one, the linear speed, whatever the speed that this turns linear-wise, is going to be the same for the smaller. So although the angular speeds differentiate, So you're going to have the angular of the larger, that's omega of the larger, and angular of the smaller. Those will be different because obviously the smaller will rotate faster than the larger one. The linear speed is going to be the same. So we're going to take the linear speed and convert it back to the angular speed for the smaller pulley. So the smaller pulley is 8 cm, and our conversion rate back is the fact that our linear speed equals radius times the angular. So we have the linear. I'm going to bring it over here. 125 pi over 6 equals our radius that we want is 8 cm, and we're trying to find the angular speed of the smaller one. So we simply divide by 8. And then we can reduce where we can. And we can't. 6 doesn't go into 125. 3 doesn't go into 125. 4 doesn't go. So we simply multiply it out, and we get 125 pi over 48 radians per second. Now, sometimes it's nice just to kind of do a little logic check, and you can see that the angular speed (25 pi over 18) is going to be slower than this speed, of course, because the smaller pulley is going to turn faster. But the linear speed is going to be the same for both.